Hello and welcome back everybody to a new episode of my daily integral challenge. Today we're going to take a look at partial fractions and the integration that comes along with it. So we're going to start the timer right away and I'll time my explanations as well. Alright, partial fractions are a pretty helpful tool whenever you want to integrate something of this nature. If you have a polynomial in the top and a polynomial on the bottom, and the degree of the polynomial at the top is lower than the one at the bottom, you rarely have any chance to go around it. What other things you sometimes can use is if you have the differential of the denominator at the top, but this is clearly not the case because we have x to the third power and x to the second power, and we don't have an x squared at the top, so that won't help us. So what we're going to do instead is partial fractions, but let me first write this a little bit prettier. The first thing I'm going to do is take a look at the denominator and factor out the x. So we have x plus 2 over x times x squared plus 4x plus 4 dx. The next step we're gonna take is completing the square at the bottom. As we can see, we already have a perfect square right here in the parentheses, so I am going to do just that. I have x plus 2 over x times x plus 2 squared dx. And now a beautiful thing happens. We have the same thing at the top and the same thing at the bottom, so these things will cancel out. The only thing on the top left is a 1 and the square at the bottom just disappears. So what we end up with is the integral of 1 over x times x plus 2. When it comes to integration, something we really don't like very much is integrating products. Instead, we would really prefer to integrate a sum instead. So what we're going to do is we're going to make a sum out of this fraction. We have 1 over x times x plus 2 is equal to something over x plus something over x plus 2. As you can see, I'm only taking the two factors and I'm pulling them apart into two fractions. I can do that in this case because both of the fractions are linear, which means they only have an x, no x squared or x to any different power but 1. And at the top, because they're both linear, I can put two constants, a and b. What I'm going to do next is multiply both sides by x and by x plus 2, so that I end up on the right side with 1 and is equal to a times x plus 2 plus b times x, because the denominators just cancel out. Now I'm going to factor out on the right side. I'm going to be left with 1 is equal to ax plus 2a plus bx. Now I'm going to factor out the x on the right side. I'm going to end up with x times a plus b plus 2a. Alright, now I can compare the coefficients. As I can see, on the left side I don't have an x. There's no x here. But on the right side I have this x, which means this part here needs to disappear. It must be 0. That's a conclusion I can draw. So a plus b must be equal to 0. And this constant part back here, whoop, I shouldn't throw it around like that. This constant part right here, needs to be equal to 1. So 2a must be equal to 1. Which leads to a must be equal to a half. So I can solve the top part, the line above, to b must be equal to negative 1/2. And now I have figured out my two constants, which means I can rewrite the entire fraction up here into the integral of 1/2 over x plus, well then, no, I'll do it like that, plus negative 1/2 over x plus 2 dx. Let me put parentheses around this. Okay. So now I can pull the integral apart, which means I can do it like this. And let me put the 1/2 already into the front. 1/2 times the integral of 1 over x dx plus negative 1/2 times the integral over 1 over x plus 2. Now we only have linear parts in the denominators, which means I can just use the natural log for both of those. So I have 1/2 times the natural log of x, and let me just put it right here on the side. The integral of 1 over x plus an arbitrary constant c dx is equal to the natural log of x plus c. Okay. Which means I have negative 1/2 times the natural log of x plus 2. And that's already it. Thanks everybody for watching. Leave comments if you have any topics you want me to talk about. I already received a couple ideas on topics I should talk about. For example, next video is going to be on sound waves, and I have another video coming up about L1 and L2 regularization. Alright, I'll see you in the next video.